Welcome to Lesson 5 in Unit 20, What Energy Does. In this lesson, students will answer the question, how can we apply our knowledge of energy and speed to engineer the best ramp for the job? In the previous lesson, students discovered the relationship between energy and speed. The more speed an object has, the more energy it has, and the more energy it transforms during a collision through sound or heat. Now students will design a ramp that gives a ball enough energy to move a specific distance. Students will adjust the height of the ramp and the type of ball used in the design to make a ball travel as close to 50 centimeters after a collision as possible. In the Engage portion of this lesson, discuss these question prompts with the class. Allow students to turn and talk, then share a few answers to the whole class. Tell students that today you will use what we have learned in previous lessons to control the amount of energy that is produced. In the Explore portion of this lesson, students will complete the Ramp Design Challenge by using the Engineering Design Cycle on student page 18. Ask students, why is this a loop? How do you know when you are finished with your engineering design? Be sure to emphasize that the engineering design cycle goes on and on until either your time runs out or your design is perfect. Next, put students in 6 groups. Each group gets one set of balls, one half of an empty cup, ruler or tape measures, and enough books or blocks to make a ramp. Distribute the Ramp Design Challenge found in the student pages. Instruct students that they must control the variables and try to make the second ball roll as close as possible to their cup without actually touching the cup. The first ball can be released, not pushed or thrown, on the ramp, and the second ball should be placed at the base of the ramp. Each team must place the cup the same distance from the bottom of the ramp. That would be 20 inches if using imperial units, or 50 centimeters if using metric. They can change which balls they use and the height of their ramp, but they cannot use any other materials. Guide students through the engineering design cycle to demonstrate how this process supports this challenge. Make sure that students record each trial, including the balls they used, the height of the ramp, the result, and what adjustment they should make on their student page. Students should perform 3 trials for the 2 different setups that they've created. This gives them more data to inform their redesign. They should also refer to the project rubric on student page 21. Guidance can be found in the teacher pages. After the appropriate testing time, each team should present their design to the class or have groups move around the room in a gallery walk to see each other's designs. Once each group has shared their design, have students record the strengths in other groups' designs that they would like to incorporate in their own. Students should evaluate themselves and their peers based on the Ramp Design Challenge rubric. In the Explain portion of this lesson, there are several videos available to view. Watch all of these videos if time permits, otherwise one would be enough. Ask students about the energy that they see and how the energy was controlled. Check out this trick shot! After viewing one or more of these videos, discuss these questions with students. They should respond at this point that motion and sound are evidence of energy. They should also note that in the videos the people had to either hit or throw the ball with the right amount of energy. If they used too much energy, it would go too far. If they used too little energy, it wouldn't go far enough. In the Elaborate portion of this lesson, these discussion questions connect what they have learned in their ramp challenge to their own lives. Have students brainstorm responses in their groups, then share their answers with the class. Students should write their ideas on the Energy Applications student page. Guidance for their responses can be found in the teacher pages. In the Evaluate portion of this lesson, students will reflect on these question prompts. Have students record their reflections in their student page for this activity. To conclude, tie back to the original phenomenon video that students watched in Lesson 1. Ask students, what have we figured out so far that could help us explain how the girl was able to take out the trash using her invention? What questions do you still have about this? By the end of this lesson, students will have adjusted the height of the ramp and the type of ball used in the design to make a ball travel as close to 50 centimeters after a collision as possible. Students will be able to transfer the design solutions in this lesson to the machine that they will create in Lesson 9.